Let's take a look at a couple more difficult problems with completing the square, namely that we now have a leading coefficient that we have to deal with as well. And again, like I said, there's a couple different ways of dealing with the leading coefficient. The way I'm going to do it is because I want to make sure that we preserve the value so that we're getting the equation in vertex form, not just for solving the equation. Other methods are more streamlined for solving a quadratic equation using the process of completing the square. But I'm more interested in being able to write the equation in vertex form without any alterations. So the first step stays the same. We want to move our constant to the other side. So 2x squared minus 4x plus something equals 5, plus that same something. Now we want to deal with the leading coefficient. I don't want to get rid of it, but I do want to take it out of the lead and factor it so that I can make my perfect square trinomial. Well, if I factor 2 out of 2x squared, I have x squared. If I factor 2 out of negative 4x, I have negative 2x. Now, I can't see it, but I am factoring it out of this box, which means in order for my equation to stay balanced, I need to factor a 2 out of the other box, which means on the right-hand side, we're going to be multiplying by 2 because we factored out a 2. Now the process is pretty much the same. We identify our b value, which in this case is 2. Notice how our b value changed from here to here. Our b value is now 2, not a 4. So 2 divided by 2 squared gives me 1 squared. 1 squared is 1. Now we'll go ahead and we can factor x minus 1 squared. That leading coefficient of 2 is just coming down for the ride. The right-hand side, 2 times 1 is 2, plus 5 is 7. Now we've completed the square. We can go ahead and use our square root property to solve. But this time we want to make sure we divide by 2 first. X minus 1 squared equals 7 over 2. Square root both sides. X minus 1 equals positive and negative square root of 7 over 2. We need to rationalize, so we need to multiply the top and the bottom by 2, so that way we end up with square root of 14 over the square root of 4, which we can simplify as the square root of 14 over 2. Lastly, we add 1 plus or minus the square root of 14 over 2. So not much different. We just have to make sure that we're dealing with that leading coefficient and make sure you're paying really close attention to how your b value changes as you factor that out. To add a little bit more complexity, let's look at d. Same process to start. We move the 2, add our boxes. But here, note that when we factor out our leading coefficient, 5 isn't evenly divided by 2. So we're left with a fraction, 5 halves. We still follow the same procedures, but now our b value is 5 over 2. So we have 5 over 2 divided by 2, which gives us 5 fourths. 5 fourths squared is 25 over 16. So we put 25 over 16 in both boxes. Now the left side we can factor k plus 5 fourths squared. And the right side adds to be 41 over 8. We've completed the square. Now we can go ahead and use our square root property to solve. Divide both sides by 2. 41 over 16. Square root both sides. Positive, negative, square root of 41 over 4. And then we subtract our 5 fourths. Negative 5 fourths plus or minus the square root of 41 over 4. Again, if you want, you can write it as a singular fraction over the common  Let's keep it going. This one, the first step's done for us. The constant's already been moved over. We just need to put in our boxes here and here. And we can go ahead and factor out our leading coefficient. So when we factor out a 4, we end up with z squared minus 1/4 z plus our box equals 39 plus 4 times the box. Our b value is 1/4. So 1/4 divided by 2 is 1/8 squared. So 1/64 goes in both boxes. We can factor now. Z minus 1/8 squared equals 625 over 16. We've completed the square. Now we can go ahead and use our square root property. Divide both sides by 4. 625 over 64. Square root both sides. Z minus 1/8 equals positive negative 25 over 8. Add 1/8 to both sides. And now, since we actually have two rational values, we can evaluate the two answers completely. 1/8 plus 25 over 8, 1/8 minus 25 over 8. 26 over 8 equals 13/4. Negative 24 over 8 equals negative 3. So x equals 13/4 and negative 3. Lastly, here are x terms on the wrong side, so we need to move it over. Minus 24x with our box, negative 13 plus the box. Factor out the 9. 24 divided by 9 reduces to be 8/3. And 9 times whatever's in our box. Our b is 8/3 divided by 2. So we're going to have 4/3 squared, which is 16/9. We can factor x minus 4/3 squared, and the right side simplifies to 3. Divide both sides by 9. I'm not going to reduce this fraction because 9 is already a perfect square, and I don't want to have to rationalize later. Square root both sides. X minus 4/3 equals positive negative square root of 3 over 3. And then we go ahead and add 4/3 to both sides. And we could leave it as two fractions or as one singular fraction. And there's completing the square.